Alrighty guys, we're going to go ahead and finish the rational functions, which was day 3 notes. We talked about the horizontal asymptotes and the slant asymptote, and then don't forget another word for slant asymptote is the oblique asymptote, and then the end behavior asymptote. So refresh your memory on those notes, but we're going to go ahead and look at example B right here on part 3. So increasing, decreasing by hand. Anytime you see by hand, well, that's telling us without the calculator. So we're gonna go ahead and try that. Okay, so let's look at example B. First, what I would want you to do is I would want you to factor. So let's see if we can factor the numerator. Should turn into x minus 1 times x minus 1, and then all over x plus 3 and x minus 2. So those are the factors of the numerator and the denominator. I'm going to zoom in a little bit so you can see. Okay. Now what we're going to do is we're going to see if anything cancels, because remember, if anything cancels, those are called the wholes. Unfortunately, nothing cancels. So we're going to go ahead and start off with the asymptotes. First, I'm going to create an x and y axis. X-axis, y-axis, and then I'm going to start off with the vertical asymptotes. So my vertical asymptotes here would be x equals -3 and x equals +2. So here's -3, 1, 2, 3, and +2. Alright, so again, we're going to have two vertical asymptotes on this example. Let's do the horizontal asymptote. It looks like it's going to be eats to c since the exponents are the same. So then we're going to divide the coefficients. So it looks like 1 divided by 1 gives us y equals 1. So y equals 1 would look right there. And there's my horizontal asymptote. Now, for the fun part, we got to figure out what's happening between these asymptotes, because we know we're going to have curves, we just don't know what the curves are going to look like, and that's what we need to figure out. One other thing I want to mention is the x-intercepts. So if you remember our song, in the song it says x-intercepts are found in the numerator. So our x-intercept is going to be at 1, 0. So 1, 0 is going to be right here. All right. Now I'm going to go ahead and do this without the calculator, but I will use the calculator to check my work. So keep your calculator close by just to check our work. The next thing we're going to do is we're going to find a value on the right side of this asymptote. And by the way, I want to tell you guys something. Notice the denominator pieces. These are where our vertical asymptotes are, and notice the multiplicity. Remember, multiplicity represents the degree. So they both have a degree of 1. If they have a degree of 1, that means around the asymptote, so look at x equals 2, this is our x equals 2 asymptote, that means one of the curves is either going to go down and the other one would go up. They're going to be going in opposite directions, because they have a multiplicity of 1. If it had a multiplicity of 2, then that means the curves would be going in the same direction, either both down or both up. That's a multiplicity of 2, 4, 6, 8, 10. So basically, a multiplicity of even gives us the same behavior, going either both downwards or both up towards the asymptote. So do you guys notice how the multiplicities here are 1? Therefore, they're going to be going in opposite directions. I'm hypothesizing that this one is going downwards, since we have a point underneath this asymptote and in between these two asymptotes. So if it's going to go downwards, then this one should go upwards. But let's not assume anything. We're going to go ahead and plot some points. So I'm going to go ahead and try x equals 3. What would happen if I substituted x equals 3 in for x? So 3 minus 1 is 2. 2 times 2 over 3 plus 3 is 6 times 3 minus 2 is 1. So it looks like a 4, 6. All right, which means we have a coordinate at 3, 4, 6. Or maybe I should simplify that, 2/3. So 3, 2/3. Well, this is 1, so I'm going to say it's going to be down here. Okay. Now, let's try. So we have 1, we have 2. Let's just try one more point. Let's try 4. Because do you guys see how this point ended up underneath the asymptote? And I had hypothesized that it was going to be above. Okay, so let's try x equals 4. X equals 4. And I'm going to plug in 4, so that's 4 minus 1. 4 minus 1 is 3 times 3 over 4 plus 3 is 7. And 4 minus 2 is 2, right? So that's 9 over 14. 9/14. That's going to be smaller than 2/3. So not 2/3. So 9/13. I'm sorry, 9/14. And 9/14. Let me double check that. 9/14. 0.642, so, and 2/3 is 0.66, right? So it's just a little bit shorter here. Oh, down here. Okay. Okay. Let me try another point. Let's try. We got 1, we got 2. And let's try. This is not going to be a pretty one, but 1.5. Because we have, I want to figure out what's going on right between these two. So I'm going to do it over here. X equals 1.5 or 3/2. So let's plug that in. 3/2 minus 1, that's 1/2 times 1/2 over 3/2 plus 3, that's 9/2. And 3/2 minus 2 is -1/2. Well, I know one of these halves can cancel, leaving us with a negative. So 1/2 times 2 over 9, -2/9. I multiply by the reciprocal, gives us a -1/9. So -1/9 would be really close. See right here. And this is what I'm talking about. What's going to happen is I know this curve is going to go down this way. And then we got to figure out what's happening on this other side. But this curve, if this curve is going down, then no doubt about it, this curve has to come from the positive infinity side. And remember we talked about how sometimes we can intersect the horizontal asymptote. And I know it's super frustrating, but that's what's happening here. What's going to happen here is this curve is going to come back up towards the asymptote, but it will never ever touch on the ends. We talked about in the middle, anything can happen, but on the ends, it will not intersect the asymptote. So this is what this curve looks like, and I'll show you on the calculator so you get a better picture, but I know it's not very pretty. This is what we have so far. All right, let me plug another number. Let's try -2. So when x equals -2, I'm going to plug in -2 into my formula. -2 minus 1 is -3. -3 times -3 is +9. -2 plus 3 is 1, and times -4. 1 times -4, so that's going to be -9/4. -9/4 is like -2 1/4. So at -2, it's going to come back down 2 1/4 right here. So what you're going to see is the curve's going to come up like this. Now remember, we talked about if the multiplicity is 1, then the curves will be acting in opposite directions. So I know this curve has got to be up here. We don't know if it's going to intersect the asymptote again. Let's try -4. And I apologize for my shakiness. Let's try -4. X equals -4. -4 minus 1 is -5 times -5. Isn't that positive? 25. Negative 4 plus 3 is negative 1 times negative 4 minus 2 is negative 6. So 25 over 6 is the y coordinate, which is going to be a little bit more than 4. 1, 2, 3, 4. So it should be more up here. Put the point here. And then what's going to happen is it's going to come down and not approach the asymptote again. So here's my picture. We do need to talk about what's happening at the asymptotes. So I'm going to go ahead and probably write that up here because I'm low on room. Sorry about that. Let's see. So I'm going to say the limit as x goes to, we'll start with negative 3. That's this asymptote here. From the negative side, so from the left side, f of x, if we look at negative 3 from the left side, where is it going to? You want to say positive infinity. But the limit as x goes to negative 3 from the right side, this is the right side, f of x is going to negative infinity. So that's the end behavior, but we don't actually call it end behavior because it's not happening at the ends, it's happening at the asymptote. So this is called vertical asymptote behavior. Now we have one more vertical asymptote, and that's x equals 2. I ran out of space, so let me try it over here. The limit as x goes to 2 from the left side, f of x is approaching from the left side, looks like negative infinity. And then the limit as x goes to 2 from the right side, that's going to be from the right side is going up to positive infinity. And there you have it. Double check your work. Wow, can't even box. Double check your work with a calculator. And this one is low on batteries, but that's okay. I'm going to plug in, if I can type, alpha y equals, I like that little tool. We can do the original, x squared minus 2x plus 1 all over x squared plus x minus 6. We'll graph it, and you're going to see that funny looking graph. And you know what? Should find the y-intercept because it looks like the y-intercept might be cutting it closer to 0. So this is the only part that I would double check on. Other than that, looks pretty good. All right, thanks guys.